Welcome to our CAE presentation of the analysis of jet turbofan by using the ANSYS workbench. I'm Kong, and this is Reddy, our geometry and machine expert, and also we have Kenjo, our post-processing expert. So we will analysis of the three key points. They are geometry, machine, and the post-processing. So Reddy, can you tell me something about the geometry progress?
Exactly. So we meticulously designed the blade and then imported into the NC workbench. And here the example that we did. And there, we set up our fluid domain, and this domain simulates the environment in which the blade operates, each capturing the interaction between the blade and the airflow.
Wow, so fascinating already. So can you explain me why setting up the fluid domain is so important?
Certainly. So the fluid domain helps us to simulate the real-world condition. By accurately defining this domain, we ensure our simulation reflects how the blade would perform in the actual turbofan by considering all aerodynamic forces acting on it.
Great insight, really. So moving on to the next step, so let's discuss about the machine. So Wendy, can you tell me more about this process?
Of course, meshing involves dividing our fluid domain into smaller elements. Kenjo, do you remember the challenge that we faced while doing the meshing process?
Yes, getting a fine balance between a fine and coarse mesh was critical. A finer mesh around the blade surface was necessary to capture the boundary layer effects accurately.
Exactly. So we use the ANSYS meshing for this. And this is an example that we did for the turbofan in the meshing process. So we're applying a thinnest mesh to area close to the blade for precision and a coarser mesh further away to the reduced computational load. This balance is the key to efficient and accurate simulation.
I see. So Kenjo, can you elaborate on how you ensure the merge quality is up to the mark?
Sure, Kong, we tune parameters like skewness, aspect ratio, and orthogonality to ensure high-quality meshes. This step is essential because a poor quality mesh can lead to inaccurate results and longer computation times.
So thank you, Kenjo and Reddy. So for now, can you move on to the post-processing process? So Kenjo, can you explain me for that?
Sure, Kong, once the simulations are complete, we move on to the post-processing results. The post-processing results highlights the inner machinations of the turbofan, so we can use it to obtain information on how to effectively design the turbofan. Here is the pressure contour, and here is the turbulence contour. These are the streamline contours, and finally we have the velocity contour. All of these are very important in ensuring optimal efficiency in the design of the turbofan.
So thank you Weity and Kenjo for both of your insights. And thank you for watching our presentation video. So for more information, you may refer to our detailed reports. Bye.